Hello. So there are some questions about example 9, page 239, chapter 4 of the Anton. That is the example about logistic curves, and in particular how to take the derivative and the second derivative of this kind of function. So the function is y equal to L1 plus a, the exponential of minus kt. Okay, so this is our starting point. Now, if we want to derive this, let's see what we can do. So, the first approach will be the one in which you just take dy over dt and go on taking the derivative of this. Now this is kind of, let's say, long and boring. There is a better, you can do that, there is no problem, but there is a better way. So the better way goes through the implicit differentiation. Now implicit differentiation means that we are going to write a formulation and then we will take the derivative and we will just indicate the derivative of y over t. Now, let's see how this works. Let me delete this one. And if we want to take derivatives, now you know that the derivative of the exponential, it is very, very easy. It's very convenient. What about the derivative of something like this? Well, something like this is much worse, is a mess. The only difficult part, not difficult, but the only part where there is a real derivative is this one. That is an exponential, so it's nice, but everything is organized in this way, and this is something that makes everything very difficult. So the thing that skilled and experienced mathematicians does at this point, and I know you still are not experienced mathematicians, but what you could do is to reorganize this expression, this formula. And if you want to organize, well, first thing you want to get rid of the denominator. So let's just get rid of the denominator. So I can write 1 plus a, the exponential of minus kt y equal to L. And this can be rewritten like y plus a y e minus kt equal to L. Okay, that's much better. Now, what we have here is something that has no denominator, and we like this. But it's not a big problem, we could even skip this step, but let's say that the only problem is that here we have a negative exponential, and what we want to do is to get rid of that, even that one. So let's just multiply for e power to kt, and let's see what we get. So if we do that, we have y e kt plus ay equal to L e kt. Okay, so now what are the parts that depends on t? Well, y and the exponential of kt. Right. So let's now try to take derivative of all these left and right term. Let's take the derivative respect to t. So we have, for example, here there is a product, so as usual I need to take the derivative of the first term times the second plus the derivative of the second term times the first term. So that means derivative of y over the t. Stop. This is implicit. we are not writing anything here. This is the implicit differentiation. Let's go on. A kt plus the derivative of the second term times the second. Well, the derivative of the second term here is easy. It's k e kt. Now, as you can see, there is some work to do, but every step is very easy. Times y plus a dy over dt. And this is equal to L k e power to kt. Okay, where are we? Okay, what we are interested in is dy over dt. This is the final result that we want to get. So let's go on, and from this, I don't want to get rid of everything, so let me just delete part of the page. You took note of the steps. Okay, so we are interested basically in dy over dt, so let's just compute that. So let me take this part on the right and group together dy over dt and put in the denominator. That means that dy over dt is equal to, well, first of all, L k e kt minus k e kt y. Okay, and we can see that here we will be able to group something over, well, over a plus ekt, right, from these two terms together. Okay, let's go on writing and see what we can get. So let me write ekt, and this is L minus, sorry, k e kt, L minus y. That's nice. And the denominator is a plus ekt. This sounds familiar. In fact, if you look at this and compare with this one, you can see that you could just group here ekt, and that means that would be a e minus kt. You can see that the product of these two terms gives a plus 1. And let's see, this goes away with this one, and what we get finally is something that we can recognize a big part of this result with the original y. Can you see the denominator is the same? So there is just an L missing, so you can put L, L, and we are not changing anything. And let me circle this part. This is y. So finally, you already understood where I'm going. Let's see, I have a few seconds before being cutting out by the software. That is a mobile one, but no rush. So I can write that dy over dt is equal to k y L minus y over L. And this is the right result. The second derivative is similar. Try to do by yourself. If you can't, just come back to me and I will post another video lecture. Thank you.